Alrighty, in this class, we are going to be talking about energy, and the units for energy are always going to be joules. And all types of energy you can define as the stuff that makes stuff do stuff. And the three types that we are going to focus on are the following. The first is kinetic energy. So this is anytime anything is moving, it's going to have kinetic energy. If it's not moving, then the kinetic energy will be zero. The equation for kinetic energy is 1/2 times mass times velocity squared. Your mass needs to be in kilograms, and your velocity will need to be in meters per second. Gravitational potential energy is the energy something has because of how high up it is. And we always need to pick where zero is going to be. So, zero could be the floor, and you could be talking about how high the ball is above the floor. And the higher up it is, the more gravitational potential energy it's going to have. Or you could have zero be the tabletop, and then you're going to be talking about how high it is above the tabletop. Or you could say sea level. But for example, San Luis Obispo High School is, I don't know, about 300 feet above sea level. I'm not going to say that my tennis ball is at a height of 302 feet because I'm going to drop it from 2 feet above the floor. That just is silly. Because then I would have to say, oh, well, it starts at a height of 302 feet and falls to a height of 300 feet. Well, that just gets ridiculous. So when we talk about gravitational potential energy, we need to pick where zero is going to be, and we just need to be smart about it. And we're going to be talking about, like, where does it have the most kinetic energy? Okay. And then where does it have all of the gravitational potential energy? How far is it falling? So basically, you are always going to be using the floor as a height of zero, or the tabletop as a height of zero. Gravitational potential energy you calculate by doing mass times gravitational field strength, or little g, times your height. Remember, height again needs to be in meters, mass needs to be in kilograms, and g on Earth is 9.8. And the problems that we're going to be doing, you basically are going to always have the problem happening on Earth. So g will basically always be 9.8. All right. And then what I would like you to do is pause, and I want you to go to the PhET simulation. So go ahead and Google PhET Energy Skate Park. And what I would like you to do is play with this a little bit. And so you are going to go here, and I want you to click, and you could either go here to where it says intro or measure or graphs or playground and kind of play with it. You can change all kinds of different things. So here you can click this little plus sign, and then it will show you the bar chart for energy. Over here, you can click this checkbox so that way you will have pie charts. So example, like if I put this person here, I will now have a pie chart for that person. You can also turn on your speedometer and look at the path that they're taking. You can have it stick to the track or not. You can change the type of track. You can change the friction. You can change the gravity. You can change the person. You can change the mass. And so, what I want you to do right now is you're going to go here, and I want you to play with it. And while you're playing with this simulation, I want you to think about these questions. I want you to think about, where is the kinetic energy the biggest? Where is the gravitational potential energy the biggest? Where is the person or animal when the kinetic energy is zero? Where is the person or animal when the GPE, or gravitational potential energy, is zero? What is the gravitational potential energy when kinetic energy is the biggest? What is the kinetic energy when gravitational potential energy is the biggest? What happens to the total energy when the person or animal goes from the top of the skate ramp to the bottom? And if you know the numbers for the kinetic energy and the gravitational potential energy, how do you calculate the total energy? So go ahead and think about these 8 questions. Pause this, go ahead and go back and forth between the simulation and this video and see if you can go ahead and answer all of these, because these are really important before you get into the worksheet. And then I'm going to also talk a little bit about spring potential energy. So spring potential energy is the energy stored in a spring when that spring is compressed or stretched. And if there is no spring, then we don't have spring potential energy. So don't let it catch you up and mess you up, because some of these problems, there aren't going to be springs in, so don't worry about that. All right, so the equation for spring potential energy is 1/2 kx squared. So that k is the spring constant. So if you have a really strong spring, for example, like the springs under your car for the shocks, those are really strong, or the springs in a recliner chair, those are really strong. But the springs in a mechanical pencil are very weak. Those are really easy to stretch or squish. And so the spring constant tells you just how easy or how hard it is to stretch or compress the spring. And then X is how far the spring is compressed or stretched. Now, this part gets a little bit tricky, and it makes sense once we talk about it. But if you have your equilibrium, so this is how long the spring is going to be if you don't do anything. If you just put the spring there and just let it sit on your table, this is how long it's going to be. And then if you compress it, if I squish it, let's say I make it so that it's smaller now, X is this distance. It's the difference between where it was when you weren't touching it and where it is now when you've pushed it to make it smaller. Or you could pull it, and you could pull it from equilibrium and you could make it stretch this much. And then X is going to be how far you pulled it to make it stretch. So just be careful that in these problems, I'm going to give you how long this spring was originally. And then I might give you how long it is when it's compressed. And instead of using either of those numbers, you're going to have to figure out the difference between the two, because that is what X is. Let me know if you have any questions. Otherwise, good luck.